Hello everyone, this is Cesar Soldiver and welcome to your Anemone 101 course. So this tutorial we will learn how to deal with loops using Anemone, a powerful plugin for Grasshopper, in order to create recursion. In order to make the best profit of this course, you should be already aware of Grasshopper, the main interface and components, the workflow, and basic stuff. Okay, so let's get started. First off, we need to install and then download and install Anemone, which we can download it from the Food4Rhino website, which is this one, food4rhino.com. Type on the search engine Anemone, just like that, Anemone. And in the search results, just go to the first one, which is Anemone, is the one we're looking for. We will go to the website of the plugin, which is this, and go to the bottom of the website. Here you will find all the versions to the plugin. Just look for the latest one, which is Anemone 0.4. You need to log in or sign up in order to download the plugin. Once you've done that, you will get a single file, which is this one. It's the Anemone component actually, which we need to install in Grasshopper. So let's go to Rhino and type in Grasshopper. We need to go to File, Special Folders, Component Folder. We'll make this smaller. Once we've done that, go to the file you just downloaded, copy, paste it in the Component folder. After we've done that, close Grasshopper, type in Grasshopper and load plugin, and type again Grasshopper. Okay, once we've done that, we will realize we got a new tab called Anemone, where we will find all the components of the plugin. Okay, so let's get started. First off, I will explain what is a loop. Okay, well, talking about the traditional programming workflow, if we want to draw a line, for example, we would have to write a line of code that performs this action. If I want to draw 2 lines, I would have to write 2 lines of code in order to do so. Or if I want to draw 10 lines, I would have to write 10 lines of code, which at the moment doesn't seem to be a big deal, but this becomes very problematic when we start dealing with large amounts of data and functions, actions, for 2 main reasons. The first one is we would have to write 50 lines of code or 50 components of Grasshopper or processes in Grasshopper, which becomes very problematic and ineffective. And the reason number 2 is that we would have to store, say, 50 variables, declare the variables manually, and this becomes very ineffective in means of if we want to edit our functionality or our code. That's why we got loops. Loops is a recursive structure in programming that allows us to perform an action as many times as we want. So let's talk about first the starting conditions or variables. Say I only have one x variable, not 50, the y1 variable and y2 variable. And with these 3 variables, I will construct a line at x, y1, x, y2. After that, I will process the x variable, increasing it by 1. So this time x will be equal to 1, not 0. After I've done that, I will get into a loop again and perform the action of rebuilding a line, and so on until I repeat 50 times this action. This is called an exit condition, the 50 times. My loop will be working, will be actually looping for 50 times. So this is basically the code. In order to draw 50 lines, I am using only 2 lines of code, and this becomes very effective and very practical because I can perform a lot of actions in a few commands or lines of code. Bringing this into a programming environment, I'll go to a Python script. This is the code to draw 50 lines in my canvas. Actually, you can tell I am not writing 50 lines of code. I'm just telling the starting condition of x, which is equal to 0. And while x is smaller than 50, I will keep looping until the condition is accomplished. So I will just loop. There we go. Close this. I've just thrown 50 lines in a single loop, which is quite effective. So now going into Grasshopper, do this. Okay. Say I have a point of the 0 coordinate, and I have another point somewhere in here. Okay. And I want to move this, not the random point, which is this one. I want to move this point on the x direction based on the distance between the point and the origin. So I have to calculate the distance between these two, this and this. X vector. That will move point. There you go. I got it. Okay, I've done it, it's quite easy, but what if I want to repeat this task a lot of times? I cannot bring this output into the input of my process, because the workflow in Grasshopper is programming from left to right. I cannot program from right to left. In order to do so, what I would have to do is to copy and paste and recalculate the distance and move again. There you go. What if I want to move again? I would have to copy and paste and repeat the process a lot of times, which becomes very ineffective. So that's why we will start using loops in order to make recursive behaviors and optimize our processes. In order to do so, we will use Anemone, which is, well, this is a plugin for Grasshopper, which is very, very powerful and user-friendly, and we can deal with multivariables. We have several methods to create recursions using Anemone. We have the classic loop, which we will start with this one. We'll bring the loop start, loop end component. I always need these two components in order to loop. Okay, so I will create my origin, point 0. I will create the random point somewhere, say here. Okay, so say I want my termination condition to be 10, so I will loop by 10 times. I will use a button and I will connect it to trigger. Trigger is, well, it's a condition in order to activate the loop, to restart the loop. And data, this is where we input data, variables, numbers, geometries, whatever we want. I will talk about this feature in a moment. So we got data here. Talking about the workflow of Anemone, it's very important to always enhance this connection between loop start and loop end. We always need to have this connection active in order to make Anemone work properly. After we've done that, just double click here to activate the component. And now what we will do is calculate distance again from the current point, which is this that comes in through data, to the origin. Move it by x. And there we go, I just moved the current point, we will call it that way. After I've done that, my data processing, I will introduce the result into the loop end, which is this input for data. There you go, I just looped, it was a lot. I will reset this point somewhere closer. Here. Okay. What happens here? I moved my point. After that, the data comes into data of the loop end, of course, and goes back to loop start through the connection I just enhanced and recalculate the whole thing. So we get a recursive behavior here. There's important features we want to talk about this component. one of them, if we right click on loop end, we can actually output after the last calculation is done. So we won't see all the results progressively. Actually, yeah, there we go. We'll turn this off. We'll see actually what's happening. We have no results until I finish calculating. That's how it works, output after the last. And we have the record data option as well, which allows us to record each iteration of the whole loop. There you go, I just recorded all the iterations of my whole loop, which is very useful. Another feature of using Anemone, I'll turn this off, is that we can actually use several variables or data inputs. I can just increase it here. It's important to mention that we need to have the same amount of inputs and outputs at loop start and loop end so it properly works. So I can actually copy this and process different points in a single pass. Grab this, calculate the distance to this, move this geometry. This goes to the one. I will loop. There you go. I have two different calculations for each point. So this is a very big feature and advantage of Anemone over other plugins that allow us to loop. So this is the classic loop method. We can actually use the fast loop method, which is this one. We got the same workflow, start and end. We can actually as well record data and all that. 10 iterations. Notice we don't have any trigger input. I will talk about this in a bit. So this is data. The data will be increased by 1. By 1. There you go. Double click this. Enhance connection. And data goes here. So what's the difference between classic loop and fast loops? Fast loops actually, well, they are quite fast. I'll turn this off. We only need numbers at the moment. If I change any of the inputs at loop start or fast loop, the loop will actually update. We'll need to trigger the loop in order to recalculate the whole thing. They are quite effective many times. There's something important we haven't talked about. Is the counter. The counter is, well, a counter that tells us the current iteration of a loop. This works better with classic loop. We'll show you an example of this. There you go. We'll loop. We can tell we got the current counter or current iteration of our loop. And there's something important to talk about as well, is this exit input, which is a boolean. Actually we can, I will toggle, you say toggle. We can stop our loop at some point. It's false by default, so it won't exit the loop, it won't stop looping. If we change this toggle into true, it will stop looping. Actually, I will show you this on the classic loop thing. Remove this. Now I will create more iterations. Okay, this is true actually. If I go to false, I'm looping. Right, there's a lot of points here. If I press true, I won't loop anymore. This is like an exit condition, a break condition when to loop. But well, we were talking about fast loop. This is a common feature in all our methods. Another important thing to talk about is, we'll say we are recording data. Go to panel. We're recording data. So we got the first iteration, the second, third, the fourth, the fifth, whatever. There's a feature, a component called browse history, which is very useful. We can bring in our data here under the slider. We can tell this component to retrieve a specific iteration. I will go to 5. For example, this is the 5th iteration, this is the 4th, this is whatever we want. This is very useful when we're dealing with more complex data structures, for example, like grafted lists or whatever. It's very useful. Something else we need to talk about is the time buffer, which is this component, time buffer. We'll create a new loop, classic loop, so you can actually visualize what's going on. 20 iterations. Data will be 0 plus 1. Usually we would have to make this connection like that, right? Panel. So if I loop, it loops at a certain space. If I use the time buffer component, I can actually tell it to loop at a slower rate, for example 100 milliseconds. So if I loop, my calculations will go slower. You can tell it goes slower, right? I can go to multi-threaded to remove this. This is slower. So this is useful to visualize the results of each iteration in a better way. Another feature of Anemone is creating loop structures in external files and then import them into our Grasshopper files. We'll create a new one. We can use the internalized loop method, which is loop start, loop input, loop output. What we do here is we're actually defining the structure of our loop. Say the data will be processed, will be increased by 2. We don't have any inputs here. We are only creating the structure of the loop. We double click to activate. There we go. This is a loop structure. We will save it somewhere. I will go back to my original file. And I will use the run loop component to import the file I just saved. SNGH file. This is okay, you can tell this changed actually. I can define the number of iterations, say 10. And the data will be 1. And remember, we were increasing the data by 2. So this should be actually increasing 1 by 2 on each iteration. I will record data. There we go. 1 plus 2 equals 3. 3 plus 2 equals 4. Equals 5. I am importing a loop structure from an external Grasshopper file. This is very useful when we are repeating a same structure of loops a lot of times in the same script. Well, so this is all for this first part. Thank you for tuning in. See you next time. We'll talk about object-oriented programming and looping geometry already on the next tutorial. Thank you all for tuning in and see you on the next tutorial.